The solenoid shown in figure, produces a magnetic force proportional to current. Proportional to the current I in the coil. F is the coil. F is the coil. This is the coil, solenoid F. In that, a force is produced. You know that if you wind a coil and supply current, it becomes electromagnet. If you put any iron outside that coil, parallel to that, like this. If you put any iron here, it will move inside automatically because of a force developed by this coil. It will move. This iron will move inside. Permeability, less 800 times less than the air. That's why this iron will move inside. A force is developed. That is sufficient. The force developed in the coil is equal to Ki1. This is, instead of applying a force at this end, we can say that a force F of t is applied at this end. We can say instead the coil is given. That's all. So a current is applied I of t. Sorry, a voltage is applied E of t. Because of that, there is a current in the coil I of t. So a force is developed in the coil. That force is F of t. The coil has an inductance of L, resistance R. This is property of the coil. The coil develops a force F. The coil takes a voltage of E of t. The current through the coil is I of t. The inductance of the coil is L. The resistance of the coil is R. The force developed is F. The force is equal to K1 times I. K1 times I, where I is the current through the coil. That's all. Instead of giving simply force, it is given like this to make you confused. In addition, that it has some mechanical property also. This coil has a weight of M1. The coil has a mass M1. The coil has another property because this coil is the other end of the coil is attached to the fixed surface through B1. Dashpot constant B1. These are the two properties. This beam is, the length of the beam is L1 plus L2. At this point, the beam is hinged. You know what is the hinged? Hinged means the door is hinged. One end is hinged. That's why you can move this door. Like that, this beam is hinged at this point. That's why it can move up and down, depends upon the force. This end also moves up and down. About this point O, the other end is fixed to mass M2. The mass has the property of spring K2 and dashpot constant B2. Now, what is the direction of displacement that we have to see? If we see that because of the force developed by this coil, the displacement at this end A is x1. At this end B is definitely, if A comes down, means B will go up. B will go up. Therefore, the force developed by M2, K2, B2 are downward. Why? Because X2 upward. X2 is upward. Therefore, the force developed by M2, K2, B2 are downwards. Here, the applied force is F, that is downward. That's why displacement is downward. Therefore, reaction forces developed by M1 and B1 are upward. M1 is upward because of B1 also upward. M2 is downward here, this end. But anyhow, the reaction forces are trying to rotate the beam in the clockwise direction. Am I correct or not? The reaction force M1, B1, FM2, FK2, FB2, all the 5 reaction forces try to rotate the beam in the clockwise direction. But the force F try to rotate the beam in the anti-clockwise direction. Am I correct or not? Therefore, if you take moment, clockwise moment and anti-clockwise moment are equal. Therefore, I can say that F1, L1, this is what? Clockwise moment or anti-clockwise? Anti-clockwise moment. Anti-clockwise moment is F1, L1. Force developed at this end. Therefore, F1, L1 is the anti-clockwise moment. That must be equal to all reactional forces. All reactional forces, they try to rotate in the clockwise direction multiplied by distance where it is applied. But some forces are applied at a distance x1, L1. Some forces, some reaction forces applied at a created at a distance L2. Some reaction forces created at a distance L1. Some reaction forces created at a distance L2. Therefore, we can write F reaction forces 1 multiplied by L1 plus F reaction force 2 multiplied by L2. Two forces. Two forces, reaction forces. If you convert this into moment, it means we have to force multiplied by distance. Anti-clockwise moment, y F1, L1. The force is at this end, at a distance of L1. The moment equal to F1, L1. Anti-clockwise. Clockwise moment developed this end as well as that end. This end because of M1 and B1, that should be multiplied by L1. This end M2, B2, K2, that should be multiplied by L2. That's all. That's all about the mathematical model. So what is the mathematical model? The first equation is F equal to K1. Already it is given, but anyhow, it is also part of mathematical model. Second one is F1, L1. F1, L1 equal to F1, L1 equal to the clockwise moment developed this side are M1 d square x1 by dt square multiplied by L1 plus another force B1 dx1 by dt multiplied by L1. Therefore, we can write multiplied by L1 plus in this end, what are the reaction forces developed? Because of M2, therefore, M2 d square x2 by dt square multiplied by L2 plus B2 dx2 by dt L2 multiplied by L2 plus K2 x2 all should be multiplied by L2. That's all. So what you got? So F of t L1 equal to M2 d square x2 by dt square plus K2 x2 plus B2 dx2 by dt multiplied by L2 plus B1 dx1 by dt plus M1 d square x1 by dt square multiplied by L1. I wrote the first second. That's all. If you equate these two moments, you got this equation. You got this equation. Now divide on both sides by L1. So this L1 getting cancelled. Divide on both sides by L1. L1 getting cancelled. But we know that the displacement is very small. This is the distance L1, this is L2. The displacement is x1. Here the displacement is x2. You consider these two are similar triangles. Because displacement is very small, not R. Very small displacement, x1 and x2. That's why we can take it is similar triangles. Sides are L1. Base is x1, x2. Therefore, we can say that L1 by x1, L1 upon x1 equal to L2 upon x2. But I want to obtain the mathematical model. Write the differential equation. That's all. Mathematical model is over. We wrote the differential equation. Time domain mathematical model is over. But the second part of the question is, hence determine the transfer function x2 of s upon e of s. But x1 should not be there. To find this transfer function, x1 is another variable. X1 must not be there. That's why we found this relation. Wherever you find x1, that can be replaced by L1 upon x1 equal to L2 upon x2. Therefore, x1 equal to L1 upon L2 multiplied by x2. X1 equal, from this we can write x1 equal to L1 upon L2 multiplied by x2. Now we can write this equation. Now we can write this equation, can be written as f of t equal to L2 upon L1 m2 d square x2 upon dt square plus b2 dx2 upon dt plus k2 x2 plus, we can replace x1 by L1 by L2. Therefore, here also we will get L1 upon L2. Here, this is v1 dx1. We want to write dx2 in terms of x2. Therefore, L1, this constant came out. There is no differentiation for constant. x2, if we differentiate x2, dx2 upon dt, v1 multiplied by v1 plus m1 d square x2 upon dt square. So the entire equation in terms of x2. Now the entire equation is in terms of x2. Now we can take Laplace transform assuming zero initial conditions. Now we can find. Now we can find this equation can be written as, take Laplace transform on both sides, f of s assuming zero initial conditions. F of s equal to L2 upon L1 m2 s square x2 of s plus b2 s x2 of s plus k2 x of s x2 of s plus L1 upon L2. If we take Laplace transform of this, what you will get? B1 s x2 of s plus m1 s square x2 of s. That's all. So now you can bring x2 of s one side. What is the transfer function required? Laplace transform of output upon input. Input is E of s. But here it is in terms of f of s. So now take this. What is the relation for f of s? We have to take E of s. We have to take, that is E of s equal to, we write Laplace transform. Let it be a. E of s equal to L s I of s plus R I of s. That is equal to Ls plus R multiplied by I of s. Let it be B. Here, if you take Laplace transform, you will get f of s equal to k1 I of s. From here, you can substitute I of s. From B, you can substitute I of s from B. I of s from B equal to what? E of s upon L s plus R. Therefore, f of s equal to k1. I of s equal to what? E of s upon L s plus R. This is D, equation D. Substitute D in A. F of s can be replaced by K1. Now I am simply replacing here. F of s can be replaced by K1 E of s upon Ls plus R. So find x of s upon E of s, because E of s is the input. You see the diagram. What is input here? Input to the system is E of s. The output is x of x2. X2 is the output. That's why Laplace transform of output upon Laplace transform of input, that we have to find. The transfer function model we have to find. So here, if you come here, x2 of s is available, the right hand side. E of s is available, the left hand side. What we have to find? Output by input. Therefore, x2 of s upon E of s equal to, this will come down. This also will come down. Therefore, what you will get is E of s k1 upon Ls plus R multiplied by L2 upon L1 M2 S square plus B2 S plus K2 plus L1 upon L2 Bs plus M1 S square, whole bracket. That's all. This is the transfer function of given mechanical system. Assuming that x2 is output, E is input. That's all. X2 is output, E is input. Applied voltage is the input. This is the transfer function model of given mechanical system. Transfer function model of given mechanical system. Mathematical. In the next class, we will see mathematical modeling of armature controlled DC motor and block diagram. That we will see in the next class.